Hello, Oslo. Welcome to the Hello World Show. I'm Spencer Schneidenbach.
I'm Heather Downing.
And we are thrilled to bring you the Hello World Show live in NDC Oslo.
That's the clap part. Maybe some of you have never heard of our show. We are a YouTube channel that aims to do episodes of 15 minutes or less with visual components only that we learn from some of the masters of our craft.
That's right. And you can find us by going to the.hw.show. That'll take you directly to our YouTube channel. And you can also follow us on Twitter at the HW Show.
And if you like to follow difficult names, you can try following Schneidenbach and Coraline.
So Heather, why did we decide to do a live show?
That's a good question. We actually started interviewing our very first guests this time last year at NDC Oslo. We had such a great time doing it, we decided to let you all in on the action as well. So instead of us asking the questions, we wanted you to ask the questions. So if you're interested, there we go. Please send questions to our panelists by going to questions.hw.show, and we'll moderate them, and if they're appropriate, we will ask them. Okay, so without further ado, would you like to meet our panelists?
All right, first up, you probably know him best from Channel 9. He's a cloud developer advocate for Microsoft and interested in all things math. Please welcome Seth Juarez.
Our next guest is a machine learning aficionado, a very hard-working developer at Microsoft, and well-known for her hand-drawn speaker slides. Please welcome Tess Ferrandez.
Next up, we have an open source contributor, architect, and author, probably best known for AutoMapper. Please welcome Jimmy Bogard.
Our final guest has dedicated a lot of time to the humanitarian toolbox, is currently compiling a book on the history of .NET, and is well known for being a co-host of the fabulous podcast .NET Rocks. Please welcome Richard Campbell.
And just a reminder, you've got questions, go to questions.hw.show, ask about our panelists anything you want. And without further ado, I think we'll start with Mr. Seth Juarez, who's going to talk to us about AI and engineering.
All right. I feel like
it's getting ominous in here.
I feel like I'm on a dating show, too. Like, I need to tell a little bit about myself. My name is Seth Juarez. I like long walks on the beach. I have a little small pug. These are all totally not true. What I wanted to talk about is I wanted to spend, they said I only had 5 to 8 minutes, I think, roughly. And what I wanted to talk about was this notion of AI and engineering. Right now, whenever we think about AI, it's like this magical unicorn thing, right? And your marketing manager, Bill, comes to you probably every day and it's like, hey, we need to infuse AI into all of our applications. And they use the word infuse AI because that's what marketing has literally been saying. We need to infuse AI in all the things. You could literally tell Bill, hey, Bill, it's already in there. And he'd be like, oh, great. And they would never know. Right? They wouldn't know. You'd say it's already been infused. And so one of the challenges that I have with particular AI, and if you want to think of AI, like think of AI as like anything that makes computers seem intelligent, right? So imagine AI as this huge bubble. That's probably not a good word to use in the tech space.
Huge bubble?
Well, yeah, so imagine it's a circle. Circle. And so AI is anything that makes computers intelligent. And then inside, or seem human-like intelligent, because you can make computers seem intelligent other ways, but human intelligence. Inside you have a class of algorithms that belong to something called machine learning, right? So for example, ELIZA, do you remember ELIZA, that thing that was like the auto, what was it? The auto, there's a word for it. Someone you go to talk to when you have problems. What are those people called?
Therapist?
That's it.
There you go.
So it was this auto therapist that seemed really intelligent that literally was like glorified regex, right? And it seemed intelligent. That could be considered AI. Chatbots could be considered AI. The space that I work in is machine learning, a set of algorithms that what you do is you give it examples of the right thing and it figures it out. And so the problem that I have is when I look at these particular types of things, I see them as engineering problems, but the world currently sees them as marketing problems, right? Whenever you think of an AI marketing thing, what do you think of? Well, there's the robots, right? There's the horrible things that are going to kill us eventually and take over the world.
Terminator.
Terminators,
Yes.
exactly. You think of things that like, oh, we should be worried that these things are going to get smarter than humans. Well, there's already a lot of other things that are smarter than humans, and we're not worried about them, right? Like rocks, among other things, right? We're not worried about them. And so one of the things that I am mostly concerned about is that we tend to think of AI as something more than what it is. And so I've spent the last probably year of my career going out and showing people this is what it is. And when people look at it, like for example, my talk here at NDC, if you want to watch it later if you weren't able to come, literally when you see what it is and I say that's it, people are like, oh. And then they start asking the right questions. And they all have to do with engineering. And so what I'm going to do is I'm going to tell you briefly, and I want to make sure that I stay to time. And so I'm going to make sure if you could log in there. It went blank on me.
It's 11111.
Right. What I'm going to do is I'm going to spend briefly 5 minutes telling you about the process of actually building a machine learning algorithm that seems intelligent. For example, something that distinguishes between a dog and a cat. So whenever you have a machine learning problem, you first have to actually start with the real question. You always have to, you can't like, and this is the part that I hate. People come to me and say, hey, I want to put some AI in my program. Okay, that's like saying, hey, I want you to build a program for me. Okay.
Or maybe a brain that learns.
Yeah, or make me artificial intelligence. All right, that's like saying, hey, make me an e-commerce app. Okay. Like, you're going to have 1,000 questions, right? Is it a mobile app? How do I do payment processing? Do we have product catalogs? Are there services that I have to build? And then, of course, you have to always think about blockchain because that's super important too, right? And so that's the thing. You have a ton of questions. So with AI, you only can start with 5 basic questions. And I'm just going to talk about the easiest one, which is something that learns to discriminate between a set of things. For example, a self-driving car can be boiled down into a set of yes/no questions, right? Should I turn left? Should I turn right? Should I turn the lights on? Should I hit this person? You know, those kinds of questions. It's too soon for that, right? Those are the kinds of questions that you need to start with. And once you have that question, and you know specifically, then you need to get data that has examples of the right things. Programmers, our lizard programmer brains, always go to, I need to create a series of steps and encode it in code, right? That's how we solve problems as programmers. The difference now is you need to turn that paradigm on its head and instead give the computer the right examples and it will figure out the steps for you. That's the difference. And so once you know that you have the data, you spend probably 80 to 90% of your data, or 80 to 90% of your time looking at how garbagey your data is. Because you have to clean it up because these algorithms are not smart enough to be able to know what to do with a null value. It will crash. Or, for example, Bill in accounting is always putting age in the name field, even though you've told him 1,000 times that's not where it goes. Right? So you have to figure out how to do that. So notice that now you're getting into real questions of engineering. Once you do that, you have to run these algorithms over your data for a long time. And the thing is that you actually have to try a lot of stuff. When we think about data science, you really are doing science. But science isn't what you think it is. Science is literally glorified guess and check. Right? So whenever anyone asks me, well, what kind of learning rate should I use? Or what kind of model should I use? Or how many internal nodes should I have in my neural network? The answer I always give them is say, hey, you know, it's an easy answer. Just use science.
Does it come in a squirt bottle?
Yeah, yeah. You just spread it all over. It's like mayonnaise, like
You got
Miracle
science
Whip.
all over that.
Yeah, just put it all over it, right? And that's the important bit. And so now that you've thought about that, you're thinking, well, if I have to try a lot of things, and then I have to sweep over a lot of parameters, and I have to try with a lot of data, then it's becoming an engineering problem. Where do I run this? How long is it going to take? And then finally, when you get something to work, it produces this little thing called a model. It's literally a file with a bunch of numbers in it. That's all it is. Where are you going to put that model? When you think of Microsoft Cognitive Services, it's a model that we've trained. We've just put it behind a service. They're all models. These things are like, and I can show you them, they're like protobuf files or Onyx files or PTH files if you're using something like PyTorch. These files have extracted all the goodness, and now when you give it a new example, you give it to the model, it does the calculations, and it outputs a vector, and then from that vector you know what the right answer is. So now the other engineering question that you have is, well, what if the model goes stale? You've got to refresh it. So now you got to think about DevOps processes, right? What if you put it through a DevOps process and in 3 months you give it this data and now the model doesn't even work anymore? Well, then that means your model's no good anymore, so you've got to change the model. And now all of a sudden all of these things become engineering problems. AI is the biggest, sloppiest engineering problem we actually have. And so when you want to think about AI and specifically machine learning, it should never be about marketing. It should be about engineering. And that's where we need to start thinking about it. And that's my time. I think I finished on the 0.
Woo!
Ooh, fancy.
All right. We got some Q&A time. I'm going to hand it over to our panelists to see if they have any questions for Seth.
All right, shoot.
Yeah, so what do you say to people that want this brain?
Oh, that like I want this general AI stuff?
Yeah.
I tell them to go watch a good movie. Just watch a good movie. Like the Terminator movies are okay, right? There's a bunch of like humanity distrusting computers, and I feel like humans naturally mistrust things they don't understand. As soon as you understand what it's doing, you will not believe how dumb it actually is. And so when they say that, I'm like, okay, what's your specific question? And then I get into the engineering aspect. It's a good question.
I'm going to switch places with you.
Okay.
So you're really not worried about an ascendant consciousness being built at Microsoft?
No, no. And the reason why is because, like, okay, I'm going to put the answer in a very, because one time I was doing the same kind of panel in a different country. I think it was Israel. And somebody, like, I was talking, they were saying, well, what about computers making art? Who owns that? I'm like, well, the computer programmer. And they're like, well, that's not how they treated animals back in the day, and they were making me out to be like I'm anti-computer, and I'm like their whipping master. These things don't think at all.
They're tools.
In fact, under current computational models, we can't even model basic molecular processes.
Right.
Right? Because biology works at a quantum scale, which is different kind of computation. We can't even emulate that. And so I think, and this is my opinion, under current computational models, given our current algorithms, these things will never think on their own. They can't. It's literally learning a bunch of matrices and vectors based upon an optimization algorithm. It's not thinking. Like it turns out that if you don't think right, these things won't work. So I don't think there's a generalized AI problem. And Andrew Ng, who you might know, a professor at Stanford who knows a lot about AI, he has said that we should worry as much about generalized AI as overpopulation on Mars.
We'll leave both of them to
Eventually we'll have a problem with overpopulation on Mars, but not for a good while.
We've got some time.
Yeah.
There are other things to worry about.
Yeah.
I have a question from the audience that I can't help but ask. So, Seth, tell us, is there a risk that AI is going to dominate over all humanity?
Yes.
Did they get a close-up? Which camera is it? No. I worry about, what I worry about is what Tess is going to talk about, I think. But primarily, I worry about humans trusting these things too much, right? For example, if you build an AI to do a prediction on like your medical well-being, and you don't have a doctor like supplementing that, you could die, right? Because it might be that humans changed, the marker for that disease has changed, and so the vectors and matrices that you learned are no longer valuable. And so that's more of what I worry about, the inadvertent trust that we put in these things.
Nice. Thank you so much, Seth.
All right, next up, Tess Ferrandez.
Yeah, can you switch to my machine?
There you go.
I don't think it's on.
It is on.
There it is.
It sees black.
Oh, it's
okay.
nice.
We're doing a very visual thing here, right? Because that's what you wanted, Heather?
Yep.
Yeah.
You can pantomime, right?
Yes. So I'm going to talk about, so once you build these models, there are a few things that you can do to make sure they are as biased as possible, that they're as discriminating as possible, and there is, making them awesome. So if you can go off to my slides again, please. Oh, there is.
Yeah, I see it.
It's on.
It looks great, Tess.
It does look great from here. Whatever you had on just a moment ago when it was black.
There you go.
Hey.
Okay. So let's go back to black again. A lot of you have probably seen the Nikon Coolpix camera. It had an awesome feature that made sure you couldn't take a picture when someone was blinking, right? So you didn't ever get a picture of anyone blinking. And then they released it in Asia, and then it didn't take any pictures. Which, yeah. And then you might have seen this viral video of this guy in the middle here trying to get soap out of the soap dispenser. And for some reason he can't, because the soap dispenser doesn't recognize his hand color, but that's totally fixable. You just need to use a napkin, and then you're all done.
Oh, wow.
And then it works awesome. And also, you don't have to get foam on your hands, which is another problem you avoid. So if you too want to create these awesome AI experiences, if you want to infuse this kind of AI in your app, then this is how you do it. So some cats and dogs in my neighborhood asked me, because they know I'm like the resident ML expert on my street, and they wanted to do some AI things. Like, first off, they had an issue with raccoons eating their food, which is a normal thing. So what they wanted to do was like to do a pet recognizer. And we all know that machine learning is basically made for recognizing pets, right? So the cats went to town on this, and they realized that they had like the biggest source of data on the face of the planet was cat pictures. Right? There are so many cat pictures. You can do deep learning on cat pictures to do a pet recognizer. And they built this awesome pet recognizer, and it worked awesome. Like, the cats got all the food, the raccoons got no food. Also, the dogs got no food. But that was not a problem per se for the cats, because the cats then got more food. And then it also wasn't a problem for the dogs, because they had watched a viral video of the guy with a soap dispenser, and they had found the trick to be put on a cat mask, right? So how do you build this kind of discriminatory exclusive AI? Well, the trick is to don't include dogs in your data sets. That's the main thing you need to do do this kind of experience. Okay, so this is one of the tricks. I'm going to show you 3 tricks. The next problem we were faced with, and then the dogs got the food. The next problem we were faced with was the dogs really wanted to get some new activities, and they were kind of tired of chasing their tail around. So all the cats and the dogs had smartphones. So they wanted to build an app for just basically saying, okay, so what should I be doing today? And they found this really, really old data set that said a lot of the dogs like chasing sticks, follow the humans around, smell bottoms, and that was it. And the cats like to sleep. And they also like to sleep and sleep. So this was a really good, so they built their whole activity activity suggestion thing on this. And it was a good thing because it worked like in 80% of the cases. So basically it suggested to the dogs to go and get sticks, and the cats to sleep and sleep and sleep. A little bit like when you post an ad for a nurse job to just women, and a job for computer engineering to just men. It will work so well because like 80% of the time, that's anyways who you want to target. But the problem was that my cat, for example, she wasn't very happy with this because she's the kind of cat that kind of likes sticks, right? So she was obviously getting all these sleep recommendations, which didn't fit her, but that's okay because we don't want her chasing sticks anyways. That would mean less sticks for the dogs. And I mean, if cats were built to chase sticks, they would all chase sticks, I think. So if you want to create this kind of experience, then a couple of tips are, don't look for stereotypes in your data. Don't debias your data sets. Don't include things like gender and race and age and all that kind of good stuff. And then you'll create these kind of experiences. The third problem that I wanted to solve was, so my cat is not actually doing machine learning. My cat is doing human learning, which if you have a cat, you'll know that this is a big thing for cats. So my cat was doing reinforcement learning on me, and reinforcement learning is a little bit like when you do something and you get feedback, is it good or bad? And then you continue in the good direction, right? So I was trying to figure out what treats to give her. And cat treats are mostly like freeze-dried stuff. So I tried tofu. That is not a big hit. And then I tried fish, which she ate a few, and then she left the rest. So I was like, I was onto something, but I was not really there. And then I gave her chicken liver, which was like the most awesome thing. Like she would just eat the whole bag if she could. So normally I'm a fast learner, I have to say. So what I learned from this is always buy chicken liver, right?
Correct.
Right. Always buy chicken liver. Never ever try anything else. A little bit like when you go on Facebook and you like cat pictures, and then you always get cat pictures. Or when you go on Google and you search for something, and then you always get the stuff that kind of really applies to you, like the things that sort of augment your views or that just reinforce your views. You end up in this very comfortable but a little bit boring place, right? And how do you create an experience like this? Well, you basically just take the most naive machine learning model you can, and you just always use it and never ever put in any human input into it. So those three tricks are basically the baseline for creating these awesome, awesome experiences. Thank you.
All right, does our panel have any questions?
So we should use the internet people to feed our machine data, right? Because nothing will go wrong with that.
Are you talking for the cat pictures?
Or just in general?
Just in general. Just let all human population feed the data, just whatever they want.
Yeah.
Right?
Yeah.
That's how Tay worked, isn't it?
That's exactly right.
Just for clarity, for someone who maybe doesn't understand satire, you meant the opposite, right?
No. See, this is developers are kind of lazy.
Oh, okay.
Yeah, so these are if you recognize all three tricks, we're basically do nothing.
Minimum effort.
Yeah.
I think we can all do that.
Yeah.
Well, so we're always thrilled when it works at all.
Yes.
You think about how many times you literally wrote a chunk of code, and the moment it actually worked, that's done. Mm-hmm. So actually going back and trying to diversify it or to
I don't think you should go back and diversify. Mm-hmm. I think you should start with diversify.
Yeah. You have all been at the mercy of a bad computer algorithm when you've called and it doesn't understand the number you're saying, right? Imagine if that was your entire existence with computers and AI that was biased. That would suck.
A little bit like when you get ads for stuff you already bought.
Yeah. That's why you should like everything on Facebook, because it will screw your feed up and your friends.
Yeah. Do you only get inappropriate questions?
Yeah.
We got good ones this time.
Yes. Tess, should we be scared of machine learning amplifying our already existing biases and discrimination?
Definitely, yes. I think that along with a few other things like what should we do with the people that don't have jobs when we automate our jobs is like one of the main things we should be scared of with AI.
I think it ties in pretty nicely with what you were talking about, Seth, is that people often are over-believing the software anyway, combined with the biases.
So one thing I want to point out there is that, for example, there is this thing called word-to-vec, which is like a huge text algorithm that's built up of like text over X number of years. And it has a lot of biases in it, and it might seem like a smallish issue until you realize it's kind of like the .NET framework. If you put a bug in it, then that bug is going to propagate to anything. And you're not ever going to go back and kind of say, oh, does this actually have a problem? Because you're trusting it because it's like so big. And that's, so it's very dangerous when you do something, and especially something that some other people use.
Especially when they use it as a justification for being biased. For example, oh, the computer figured this out, so it must be right that we're all racist.
So it can't be racism.
Or chauvinist idiots, right? That's when it's a problem, because people use it as a justification.
Yeah, because with machine learning, since it's based on past data, your past is always going to be your future unless you do something about it.
Thank you so much, Tess.
Thank you.
All right, next up, please welcome Jimmy Bogard.
All right.
I'm so excited that Jimmy has art skills.
Oh, that's not true. All right, so I wanted to talk about messaging, specifically messaging patterns I learned at McDonald's.
Yeah.
Or I guess Burger King, I see that more around here.
No.
7-Eleven?
No, okay. It's whatever. So a lot of people think that messaging is this difficult thing to learn because it's only the architects that have to deal with these kind of problems. But what I'm here to tell you that we are actually surrounded by messaging pretty much at all times. And if we just look a little bit more closely at our surrounding world, you too can become messaging experts. For example, a trip to McDonald's. So when you go to McDonald's, well, when Spencer goes to McDonald's, I guess. I only go to Five Guys, I'm sorry. Okay. So when you go to McDonald's, the first thing you do is queue up. So you get in line behind everybody else to be able to take your order at the cashier. So right away, you're introduced to queuing theory. I've seen a number of different ways that people have these queues. Sometimes there are a number of different registers, and you have to figure out, like, is that register going fast or is that register going slow? Other ones make everyone get into a single line, and then the person at the front goes to the next available register. So right away, you're getting exposed to queuing theory. But when you get to the register itself, you start to have that first interaction with the employees there. So you're talking to the cashier to be able to place your order. So they first ask you a question: what would you like to order? Hopefully you've already figured it out, because people get annoyed when you haven't figured it out and you're at the front of the line. And so you tell them, I want a, Spencer likes a number 2, I think.
Quarter pounder, yeah.
Okay, there we go. I don't know why I knew that so quickly. So right away, you have a conversation you're having with the cashier. And so they're asking you a question, and you're giving them a response. And so right away, you're using a request-response pattern where they're asking a question, and you're giving a response back. So that's request-response between the cashier and you. The other thing that's happening is it's a purely verbal conversation. So you don't write down your order and then pass it over the counter to the cashier. You're telling them just face-to-face. And so right there we have non-durable form of messaging, because we're not writing anything down. We're just telling them what we have between you and the cashier. And the final thing we have is a synchronous form of communication. That is, you are standing there telling them your order, and they're waiting for a response, and you are standing there also waiting for the answer back to say how much it costs. So you have a synchronous, non-durable form of communication back and forth here. And the reason why we're doing that is because that's the most efficient way for us to have that initial interaction. If we try to write things down, pass it over, they'd write an answer back, like that would never work in the real world. So we have the most efficient way of communicating through that. Now from there, after you've given your order, you don't just stand right here in line waiting for your food. You go over here somewhere to go mill around, waiting for your order to be actually finished. At this point in time, the cashier will notify all the different stations Let's see, this is the grill station over here. This is the lettuce station.
Where's the microwave station?
This isn't TGI Fridays.
Oh, sorry.
And then, of course, we have the fry station over here, which is where all the good stuff is. So when you place an order, the cashier doesn't go around to every single person and say, okay, I need you to make a burger. I need you to make some fries. I need you to make the lettuce. Instead, what they're doing is they're broadcasting the order out to all the different stations in order for the stations to make their food. So the stations don't have to directly communicate to the cashier in order to figure out what they need to make. So we have here is a form of pub sub, where each of these different stations are being notified off a single message saying, this is the thing you need to order. The other thing we have is the cashier is writing the order down. So they're writing exactly what the person has ordered, and that is the thing that actually gets passed to all the different stations. So these people at these different stations don't directly have to talk to the order, the receipt person here. Instead, they're receiving it asynchronously. So the cashier never has to directly interact with each of the stations. So the next patterns we have are, we have a asynchronous version of communication, we have durable messages, and we have a broadcast that has one message going out to all the different stations. So far, so good? Okay, now the last piece is to actually take all the different parts of the order and then combine them into the thing that you actually get. In order to do that requires a little bit of coordination. So we want to make sure that we have a very efficient parallel processing of our order, so the burger is being made at the same time as the fries. It's not a sequential set of processing. And so because we're doing things kind of asynchronously, we have to have something that has to gather everything back together again and then actually be able to hold the order. So the way you'll see this at McDonald's or Burger King or any fast food, most fast food restaurants, what they'll do is they'll have a holding area that is the temporary holding place for partially filled orders. Now I have a bunch of trays here, and I need to make sure I can distinguish between one person's order and the next. So I need to have some way to identify who this person's order is versus the next person. And so in order to do so, you'll typically have some kind of correlation identifier, and that's our next messaging pattern. I need to have some way to identify this person versus the next person. And there's two types of correlation identifiers you'll see out there. You'll have natural correlation identifiers or artificial. So when you go to Starbucks, or what's actually a good coffee shop?
Burn.
I don't know. So at Starbucks, they'll ask you your name, and they'll write it on the cup. So their correlation identifier is a natural correlation identifier, which is your name. And hopefully your name isn't shared with anyone else, which is why I typically use like unpopular names like Darth Vader or something like that. So it's, like no one will ever pick that. Or what McDonald's uses are artificial correlation identifiers. That is, you get a number for your order that is going to be different than the next person's number and different than the one after that. So each of these trays gets a different number so that when each of these parts of the order is done, this person will go look to see which of these trays matches up with the order that they're interested in. So as they come back, again asynchronously, we'll have the person check to see, are all the pieces in this order done? And once all the pieces in the order are done, then they'll go ahead and call out your name or your number, and then you hopefully get your food. Now this pattern right here, where I have this asynchronous process that is able to have some management of trying to get these different pieces in, that is known as the process manager pattern, which is a way for us to have an asynchronous kind of an asynchronous process managing multiple different messages coming in at different points in time, and then keeping track of state to know when should I be finished with each of these orders. And so we know when we're finished, when we've checked off all the items in the list, and hopefully this person knows how to read the order. Otherwise, our order will be wrong. And so this is why at McDonald's, you will probably always check your order because you're relying on this process manager, which is typically the employee, to actually check to see if everything is done. So with this, we have synchronous non-durable messaging using the request response pattern. We have a broadcast out to these interested parties using a durable asynchronous form of messaging. And then finally, we have the process manager pattern to be able to hold the temporary state of the overall ordering process until it's finally complete and called out to you. So next time you go to McDonald's, take a closer look at what's going on behind the scenes, and then you can also become a messaging expert.
Panel, you got any questions for the McDonald's expert?
Yeah, where does the enterprise service bus fit into that, my friend?
So the enterprise service, that's a good question, actually. So an enterprise service bus is that central broker that is managing all forms of communication. So that style of messaging is more like a Gordon Ramsay restaurant, where he's screaming at people when to do different things, and everything has to go through that central person. So if you want an ESP, you can do a Gordon Ramsay style app system.
So I need to name my ESBs Gordon now.
Yes.
Okay, so we have a question that I think that probably could tie into this as well. So imagine you have more than one of these kitchens, more than one of these in a row, and that each of them are microservices. So how does this work if your data set will grow as you get more and more traffic?
How do I scale McDonald's?
Yeah.
Well, they just build another one right next door, right? No. So if I'm looking here, each person is actually the microservice, because they're an independent actor that is autonomous from every other person. So if I want to scale this out, what I'm doing is I'm adding more people to each of these individual steps. I'm not building a separate physical location for everything. I scale each individual step for whatever load each individual step has.
Thank you so much, Jimmy.
You're all microservices. Yay.
Yeah. I should have set up.
All righty, last but certainly not least, we have Richard Campbell.
Thank you. Any listeners to .NET Rocks? Oh, wow, lots in the room, holy cow. So anybody listen to a show we call a Geek Out? No Geek Outs? So there are certain Geek Outs that they are whatever geeky subject the audience wants. There's some voting going on. And there are certain subjects that I am careful about doing. And this is one of them.
So instead, you're doing it on the Hello World.
So I'm doing it for you guys instead. Because I tend to go down the moderate path on a lot of things, which means I get hate mail from both sides. And I have enough material around this particular topic now that that's a lot of hate mail. I am not going to talk about whether climate change is real or not, because it is. And if you're still debating that, well, we might as well talk about flat Earth. Our global CO2 levels are at all-time record highs for when humanity was around, but not all-time record highs by any stretch of the imagination. If you jump back to the Eocene, where we were at 1,000 parts per million for carbon dioxide, as opposed to right now we're about 425, the planet was fine. There wasn't any ice caps. And things were a wee bit wetter and warmer, but the planet was fine. This issue about carbon dioxide in the atmosphere is a human issue, not a planet issue. Don't worry about the planet. The planet is fine. It'll get through this one way or the other. This is about 34 million years ago, so well before humans were around. There were lots of creatures. This was a great time for plants. When carbon dioxide levels are this high, they grow like wildfire. Now, we know how this is happening. We're extracting carbon from various parts of the planet, and then we're consuming it in ways that ends up distributing it into our environment. So certainly oil extraction and coal extraction are great mechanisms. We are largely turning it into power. And of course, we're turning it into motion as well. And the results are fairly clear. The increasing carbon dioxide in the environment has provided warming across the planet so that we're hitting consistent record highs. Now, why is this bad? Because for the most part, the planet is fine. The issue ultimately is people. And we're starting to see those consequences now, particularly in tropic areas. We've been consistently above temperature since about 2002. We're about a degree over baseline pre-industrial times. There's almost nothing we can do at this point to stop coming to the second degree. If we were to stop emitting carbon in a meaningful way now, it would still climb to probably the neighborhood of 500 parts per million. So we're going to have to deal with certain challenges around that, and certainly part of that is we're calling environmental refugees. So typically in poorer parts of the planet, storms are coming in and farms are never draining, or they're going salty so they can't grow there anymore. And so they have to move. Typically we're creating refugees these days through war. But we're on our way to creating refugees through disrupting their environment to the point where they can no longer function in the place they need to. Now, we know what to do. This is a solvable problem. The primary issue here is managing the carbon we're emitting by using strategies to emit less carbon. So we're going to low carbon footprint power production methodologies. Certainly wind and solar are hip. We've got plenty of hydroelectric and more to be built. I'm from British Columbia. We're in Norway. It's hydroelectric land. So we're all fairly smug about this because we happen to have a strategy for making power that involves mountains, and we've got lots and lots of mountains. I have no, geothermal is an interesting particular aspect of power which people don't do a lot with for no other reason than they don't really know how it works. You pump water down to the hot parts of the ground, and sometimes it comes back up. And sometimes it doesn't. So that's why you're seeing limited adoption of geothermal. Modern nuclear power will fall into this category as well. Low carbon emission aspects of power generation. But we can't do it all at once. It takes time. There's no fast way to do this. Replacing power plants is a decadal process. And given current trends, it's going to take us about 50 years to get to near carbon neutral power generation and emission levels without serious disruption of our civilization. We depend on power. It's how we feed people. It's how we move around. It's how our society functions as a whole. And so that amount of time means we're going to miss goals by a big way. And that brings us to an interesting conversation. The conversation is not, do we do this or not, or can we do it faster? We have to mitigate. We have to deal with the impacts of climate change, independent of also getting to a neutral state. Now, there is a way to stop the planet from warming. In fact, the planet does it to itself on a regular basis. In 1991, Mount Pinatubo erupted. It's a very large pyroclastic volcano in the Philippines, and it tossed about 8 million metric tons of sulfur dioxide into the stratosphere and lowered the average temperature on the planet by 1/2 of 1 degree for a year. Enough that it was good fodder for the climate change deniers to go, look, the temperature doesn't always go up. Sulfur dioxide goes into the high levels of the atmosphere and it reflects sunlight back efficiently. And naturally rains back out of the atmosphere in a form we call acid rain, if you get it to sufficient densities. And Mount Fuego this year erupting in Guatemala is doing the same thing. We could use this strategy. Humans could be putting a certain amount of sulfur dioxide into the high stratosphere on a regular basis to moderate temperatures. So you'd be talking about extremely high altitude aircraft. They'd be 60,000 feet or above, so above typical flight levels for airliners. It's not as much sulfur dioxide as a volcano would produce. You'd probably start with somewhere in the neighborhood of 25,000 metric tons. That would be enough to moderate for about 1/2 of a degree. Now here's where it gets tricky. You're going to have to increase every year. And if you stop, the temperature jumps back up and we have huge disruptions. So this isn't a permanent solution. This is a mitigation. You can do this year over year, probably out to about 2070. So if we started in 2020, we have 50 years, we're on this track to emit less and less carbon over time. By 2070, we'd be pumping about 1 million metric tons a year via aircraft. This would be a $1 billion project, but not a $1 trillion project, so it would be manageable, and you could keep temperatures at a very consistent level. But there is a maximum threshold of how much you can pump. It becomes uneconomical at some point, and you can't just keep pushing sulfur dioxide into the atmosphere indefinitely. Now, humans already pump about 50 million metric tons of sulfur dioxide in the atmosphere, although it tends to be low levels, and we're reducing that. Shipping, currently, the bunker fuel has a fair bit of sulfur in it, and it goes into the environment on a regular basis. It won't fix everything, but it could moderate the temperatures. Same mechanisms we use to control CFCs. The Montreal Protocol in the 1980s addressed exactly this issue with CFCs. We largely eliminated them by move to other businesses. And it actually spawned more industry, creating additional technologies around chlorofluorocarbons. That's only one aspect, and I hope you see the moral hazard in this, because it's actually the talking point. Here's the next aspect. We need to remove carbon dioxide from the atmosphere, period. The natural rate of mitigation of carbon dioxide, even when we get to zero emission, is not fast enough. And there is technology that exists today to reduce the amount of carbon dioxide in the atmosphere. This company is called Carbon Engineering. It actually happens to be based in British Columbia. It is partially funded by Bill Gates. And they recently announced they've gotten extraction of carbon dioxide down to under $100 a metric ton. The problem is, nobody wants to buy carbon dioxide. So they've also found a chemical process where they can actually turn that carbon dioxide back into kerosene or gasoline. There's an interesting moral hazard as well. Because technically that would be a zero-emission gasoline. I take the carbon out of the atmosphere, refactor it back into gasoline, and give it back to you to put back in the atmosphere. But that's substantially better than digging it out of the ground and introducing new carbon into the equation. And it would make them a business. At the pricing they're talking about, each metric ton of carbon dioxide would produce roughly 1,500 liters of gasoline at about $2 a gallon. It's a business. And you could also do a certain amount of sequestration at the same time. This is geoengineering. And this is something that is being explored right now. And there are more moral challenges around this. It is easy for us to focus purely on electric cars, on power generation with zero footprint. But we're also going to we have been altering our environment for the past 100 or so years in ways we didn't intend. We are well on our way to maturing the set of skills to modify our environment in the way we do want it to be. Reducing the amount of carbon in the atmosphere will certainly be a part of that, moderating the amount that comes in there. The really interesting debate will be, what will the part per million agreed upon level of carbon dioxide be once we do have control of this? Because I'm betting it won't be pre-industrial levels. You know, one of the upsides of keeping ours somewhere in the 325 to 350 part per million range is increased growing times in temperate zones at the expense of rougher weather in the tropical zones. A little more ethical moral hazard for you to explore. This is a favorite area of mine, and I will be doing geek outs on this sometime in the future. Thank you. Seth?
The Earth isn't flat?
I also saw that both Denmark and Florida were underwater in that one picture, so
yes.
Maybe it's not that bad.
Well, oh, dark,
Jimmy.
Yeah. I haven't talked about acidification of the oceans at all, but the upside to acidification of the oceans is it's breaking down limestone really rapidly, because limestone is a natural mitigator for that, and pretty much all of Florida is made of limestone. You wonder why all those sinkholes are appearing and stuff? It's literally dissolving.
Oh, no.
So do you think common people can directly affect the climate change, or is this just a political problem?
I think, we're in Europe. I'm from Canada. I believe government is actually us, right? We vote them in. We demand certain things. Like, all those things actually are relevant. So while it is certainly a political problem, recognize that politics is policy of civilization. That I want my civilization to behave a certain way, and destroying how we breathe sucks. So we'll insist on those things, yes. But ultimately, because it is us, it is our own actions that are going to matter there. So the take advantage of putting solar cells on the roof, the ways that we reduce our individual carbon footprints are going to matter.
Do we know the fallout from some of these initiatives? Like, won't we destroy our agriculture when we put sulfur dioxide in the air?
Yes, we do destroy agriculture when we put sulfur dioxide in the air. We've been doing it for the past 150 years, but not all of it. But we had a program years ago to decrease the amount of sulfur dioxide put in the atmosphere. That's when we had the acid rain initiatives that were destroying all kinds of things. This is tropospheric sulfur dioxide, which is substantially higher. It will ultimately descend. In the concentrations that we're talking about, it will be less damaging than the damage we've already done.
Thank you, Richard.
You bet.
All right.
All right, we're going to go into a general Q&A that we actually still have from you guys. So let's see.
I think this is a good one. This is a question. It says it's for Jimmy, but I think it could go for all of them. I like that you always seem pretty confident in your tweets and writings. Do you ever feel like, what the heck am I doing? I know nothing. Start with Seth.
Yes.
It's imposter syndrome, and we all have it.
Well, the thing about it is, like, look, I trained as a data scientist, and I know I'm really good at how the math and the models actually work, but, like, I make demoware. It's my job.
Yeah.
Right? And so I stress out a lot about that. That's why we have people like Tess at Microsoft who actually doesn't make demoware, and I have colleagues like Paige Bailey who work for the oil and gas industry doing real machine learning, so that whenever, like, I have a hard time, I just ask Tess or I ask Paige. I'm like, hey, you know, I feel like I might be good at the math of this, but there's a general horse sense about AI that you tend to develop after many years of looking at data that I just don't have, right? I started as a .NET dev and then went back to school to do data science. And so yes, I have that. I don't know what I'm talking about.
For me, I think we're all just waiting for someone to call us fakes, right?
Happens all the time.
Yeah.
Dude, all I do is interview people. I have a real job. And so, I mean, I admit, people often cast the knowledge of my guests onto me because I have a good memory. But it's not, I just learned. You know, I research for a living.
But one thing I think is that on like the four of us and a lot of other people who, we kind of are the most outspoken ones, but we kind of harvest the knowledge of everyone around us and pretend that it's ours a little bit.
Yeah, I don't even think I pretend. I'm just like, I didn't write any of that. I assembled that from other sources, right?
Yeah.
University of Leeds, Harvard, like that's where that came from.
Yeah.
It's just, I subscribe to the William Gibson, you know, the future is here, it's just not evenly distributed. You know, I have time to go in and hunt down the little bits and go, did you know this is happening over here and this is happening over here? But all the pieces are here.
Yeah.
It's true. I did not invent machine learning.
Why do you keep telling everyone that?
I should have started with that.
So this was originally asked to Jimmy, so I want to hear what he has to say.
So I wanted to hear what they said first. So my very first conference I went to, I attended, was a No Fluff, Just Stuff conference. So it was the Java land. And I was super excited because Martin Fowler was going to be there. So I was like, oh, he's, read his refactoring book and the patterns of something architecture book. So I was super excited to meet him. And I went to go to the restroom, and there he was going to the restroom. And I literally went up to go shake his hand while he was
peeing.
I was like, just not. So like, of course, like I faced her, like, oh my God, I can't believe I ruined my one chance to meet him. So I did talk to him afterwards outside. He's like, don't worry about it. Like, there's not really experts here. There's just us. We're just people. We're just all here trying to learn. And so once I realized, like, no one really knows what they're doing. So it's not confidence. It's just a knowledge that we're all still just trying to figure things out. That's how I kind of get over that. I just was lucky to try to shake his hand that early in the bathroom.
Glad you waited.
He hasn't washed his hands since. That's what he told me.
We have one. We're going to close with one really big question for our panelists. Right? What would be like true added value to humanity with an AI that becomes much smarter than humans? What is the real value there?
For me, I think it is trying to solve those problems that take a lot of time to solve for a human. Like, for example, one that I really like is a Swedish company that can look at eye movements for kids that are around like preschool, and they can see immediately if this person is going to have a reading problem or not, like dyslexia or something like that, and can put in like efforts really early to because there are a lot of things you can do to not fix dyslexia, but to make it a lot more livable. Yeah.
I think it's interesting to go down that early diagnosis angle that the technology is often good at capturing subtle things that are harder for individuals to see, although you'll always meet a teacher that's extraordinary at that just has an eye for, I know what challenges that kid will have. They're just outnumbered. So if we can amplify those skills so that we can help people be their best selves.
They can actually do like analysis on all the kids.
Yeah.
Instead of just
the one lucky one that gets eyeballed, or so much of our schooling system seems to be only the extremes. The most challenged and the most capable seem to be picked out, and everybody else sort of gets left behind.
I honestly think like the first industrial revolution that we had commoditized labor, right? Because machines started like lifting things, right? And in the pyramid days, we had people lifting things, and that didn't go very well for most of them, right? And so
pyramids are still there, man.
They are. What I'm saying is that, like, machines allowed us to actually get to places faster, do certain things faster that humans couldn't do. I feel like this new revolution of AI will commoditize cheap thought. Like cheap thought. And what I mean by that is like there's things that we have to do that we're not really thinking, but we just sort of have to do, like arranging my calendar, doing my expenses, which I'm not looking forward to on Monday, right? Stupid stuff like that. I feel like AI is going to augment humanity and lift us up to the next level by commoditizing that cheap thought and allowing us to think about even more or work on even more. Like the thing that bothers me the most is not that Einstein died, and I saw this on a tweet, but that there's a ton of Einsteins out there, like maybe sitting in a refugee camp.
Yep.
Right? And so I feel like we need to up-level humanity by removing, just like when Ford started making the car, and now we can all go around and I can be in Norway in about 10 hours, right? Which is pretty amazing. I feel like we're going to be able to commoditize cheap thought in a way that up-levels humanity if we do it right and for the benefit of everybody.
Yeah, I'm really not worried about artificial generalized intelligence.
Me neither.
Because we'll destroy the planet with artificial specialized intelligence way before.
Sure.
Like if we can't solve what bad actors can do with ASI, you never need to worry about AGI. We need to solve that. And that solution, ultimately, should we actually figure out what consciousness is, and let's face it, we don't know, then we'll know what to do with that.
We're not even close.
Yeah, we're not even close. Not even.
Like, I don't even know what my kids are thinking sometimes. Like, how am I going to make a computer?
So I feel like we could have something really special. If you remember the show Silicon Valley, there's a bot they were teaching it, hot dog or not.
Mm-hmm.
Well, if we had that a few years before, when Lego put out their MMORPG that they had to shut down because there were too many hot dogs that the bad actors putting there, then we could have had an actual Lego MMORPG.
Right.
Yeah.
The world would be a better place.
Exactly.
There's specialized
There's
intelligence.
a missed opportunity for humanity there.
But yeah. Sorry,
really
we didn't.
I know I feel enlightened.
This is where I'm
I
thinking.
totally
I'm on
like-
a totally
I
different wavelength, obviously. Here.
I'm not going to be able to go to sleep tonight knowing that did not happen.
All right. Well, thank you very much for coming to the Hello World Show Live. Remember, you can find us at the.hw.show. Thank you very much for coming.
And thank you to our panelists.
Yes, thank you. One more round of applause.